So can you give a warm welcome to Brooks Agnew?
I actually did not know anything about the Hollow Earth till we started writing our first book, which is The Arc of Millions of Years. Somebody brought me a book called Our Hollow Earth, and I read it, and I thought it was amusing, and I put it on the shelf, and I didn't think about it again. That was 2001. In 2004, we finished The Arc of Millions of Years, the Volume 1, which is this book right here. And it's 560 pages thick, nonfiction. It covers 44 ancient cultures who believed that Earth was actually two planets put together, a higher vibrational planet and a lower vibrational planet. And that the life force, actually, of life, of mankind, came from inside Earth. They believed, and very strongly, in a symbiotic relationship between the mortal human and the planet itself. In fact, these 44 ancient cultures spent a significant amount of their gross national product building edifices for the future, not for their society, for the future. The way they arranged their buildings, the way that they did their mathematics, the way that they recorded things on tablets and scrolls and in buildings and architecture. It wasn't for them, it was for us. It was for this day, at this time, because they had this belief that even though Earth is put together as two planets, higher vibrational, low vibrational, one day they'll come apart. So where does Hollow Earth theory come from? And is it really even a theory? Well, it goes all the way back to Edmund Halley, 1629. He had this idea that the Earth might actually be a sequential series of crusts, one outside the other, and this was the idea he had of what Earth looked like. Also from one of my ancestors. His name was Sir James Ross. In 1831, he discovered the North Magnetic Pole, which, by the way, the North Magnetic Pole has moved quite a ways from where he originally found it, and it's continuously moving, although we're only watching it from space now for 4 years. So we don't really have a lot of data yet, but we'll talk about that a little bit later too. Another guy's name was Marshall Gardner. This is 1965, and he actually patented the Hollow Earth. Yeah, so there's actually a patent about the Hollow Earth, and he explored his entire life and ended up dying of pneumonia on September 10th, 1965, while searching the tunnel openings to the interior of the Earth. He caught pneumonia and it ended up killing him. Let's also talk about Admiral Byrd. We can't talk about the North Pole without talking about Admiral Byrd. In 1926, he flew over the North Pole and back. He says that he flew over areas of lush green areas with large animals below, but he didn't send any pictures back of that. He also did the transit time a little bit fast. It was done from an area called Spitsbergen, which was a little bit of a story. They had to take this plane that you see right here, disassemble it, put it on a ship called the Chantilly. They sailed up to Spitsbergen. There's no dock, there's just a beach. So the boat's a little bit offshore. They build a floating dock by hand from the boat to the shore, and the ice is coming in. It's getting ready to freeze out. So they literally have hours to get their supplies, including this plane, in pieces off the boat, over that floating dock, onto the beach, and get the boat out of there, which they did successfully. Then they rebuilt the plane on the beach, filled it up with fuel, and took off. Ostensibly, they flew at 2,500 feet altitude all the way to the North Pole and back, which is why he's an aviation hero and not a statistic, because that's very hard to do. We tried to get pilots to do it at 17,000 feet, and they wouldn't do it, because it's a very treacherous area to fly. Worst weather on the planet. Earth-based data, we had evidence in the sea, the sky, evidence on the ice, evidence from earthquakes, and even evidence from human consciousness. So let's get into it. Let's see where it takes us. We talk about the evidence from space. We have a lot of satellites in space that look back at Earth. It's not quite perfect because the satellite goes around the planet every 2 hours. So in that 2 hours, the next strip changes a little, changes a little, changes a little. It's night, it's day, the clouds move, all kinds of things. And the odd thing about it is in over 38,000 images that we looked at of the Arctic, there's always cloud cover. We could never actually see the ground. So then in 2006, they came up with the Data Denial Act, which is what this slide shows right here. The Data Denial Act had a really key statement, and that is the data cannot be shared during times of conflict or war. Like, when have we not had conflict or war? Like, forever. So they don't share real-time images of the Arctic. It's kind of a strange phenomenon. We don't really have images of the North Pole, so that threw up a big flag for me to prove this. We think about, gee, how are planets formed? Well, we have two theories. One's called the accretion disk theory. This is where we look out on the universe and we see these big swirling clouds of gas. And inside that cloud of gas, we notice that there are coagulations. We see little stars forming in nodes around this central star, and then other little clumps around each one of those stars, which end up being planets. Now, you got to realize that we haven't been looking at the universe that long, only a couple hundred years, even with the best telescopes, not very long at all. So we have no real perspective. We get snapshots. Oh, here's a snapshot, there's a snapshot. And we try to put them together, kind of like a storyboard of how the universe is formed. But we don't really know. What we think is that this solar system formed from a giant accretion disk of gas. First the sun, then the planets around it. They arranged themselves in some Fibonacci layout, and this is what we have. Except that all the planets in our solar system are quite different in their molecular makeup, so it doesn't make a lot of sense that they came from the same cloud. But that's okay. We're still going to believe it. We're still going to put it in our textbooks. There's another theory, and that's the electric planetary formation theory. This is the end result. And what we have done is we've actually looked out in space and we've photographed a phenomenon that flies in the face of accretion disk theory. And that is that electric discharges form along a pathway, and along the pathway, stars form because of these incredible bursts of energy that pull everything together and convert energy into mass. And then the stars start generating elements like silicon and nitrogen and oxygen, tin and iron, and this is where all the elements come from. The stars are element engines, and they're like creating all this mass, and that's what actually forms the planets around them. We have other photographs. It looks like this. We can see these big clouds. Well, these aren't accretion disks. We can clearly see the stars forming in them, and we imagine that there are planets around those stars as well. But that's not an accretion disk at all. Maybe we have an electric universe instead of just a giant gravitational universe. This is actually a satellite photograph of stars that have formed in a giant ball of gas. And we can see that there are electrical discharges between these stars. That makes no sense to the old way we thought the universe was formed. On the left is an animated version of this plasma. On the right is an actual photograph from Hubble. Pretty close. Pretty close. Now, some things happen when planets form, because as this mass comes together from a large area to a small area, it begins to spin. That's called conservation of momentum. It's kind of like when an ice skater goes out on the ice and she begins to spin, she pulls her arms in and she spins faster and faster and faster because all that momentum that she had in her arm, she's now collecting at a smaller radius, which makes her turn faster. Sometimes when planets do that, they end up spinning so fast that they explode. Other times, heavy parts of the planet move to the edge and it becomes unstable. And what happens is the planet or protoplanet spits off a piece of itself as a moon. We have an example of that in our own solar system with Mercury and Venus. But the third is kind of an interesting phenomenon. I kind of call it the Goldilocks. It's planetary stability. What happens is the planet does in fact spin so fast that it begins to expand and cool, expand and cool. And when it does, it stays together. It doesn't explode, doesn't become an asteroid belt. It becomes a larger diameter planet with the same mass. Now just think about that for a second. It's sort of like inflating a balloon. The balloon has the same mass, but the surface area is changing. We think that that's what happened with Earth too, and we have some evidence to back it up. We think that planets over billions of years slowly expand. Now there's an individual out there named Neil Adams, and he did this animated version of this, and I want to share it with you because he does a much better job than anybody else at explaining this. We once thought that all the continents were fit together on one side of the planet. We called it Gondwana land. But that's been long since debunked, because those continents do fit together very nicely. Any 9-year-old can see that, but they also fit together on the other side. The continental shelves all fit together. So it looks a little something like a planet that was 1/3 its present size. So I'll be the narrator then. What happens is we begin to shrink the planet, and you can see that all the continental shelves, Africa, America, even New Zealand, and Australia, and even Antarctica, they all fit together all the way around, all the continental shelves perfectly, except that the planet is 1/3 its present size. Any 9-year-old can see that all these things fit together. Now, if we expand this planet back out, very slowly, you can see these tectonic separations begin to occur. You can see the continents and their shelves begin to re-separate, and you'll see as the planet expands slowly how they drift around the increasing surface area of this sphere. Now, if this was true, because we know Earth is 4.5 billion years old, then the entire planet should be 4.5 billion years old. But what we have found is the dry land on all the continents, all the Himalayas, all the Appalachians, the Rocky Mountains, all these mountain ranges do date to 4.5 billion years old. But the sea floor, everywhere we have tested, the oldest sea floor is only 50 million years old. The definition for a living thing. Technically speaking, a living thing should be able to respirate. It should be able to protect itself against toxins. It should tend towards stasis. In other words, if it's pushed one direction, it should push back and try to reach a center balance. And technically speaking, Earth does all those things. It spontaneously provides life. It protects itself against toxins. If it gets too cold or gets too much carbon dioxide, it grows more plants, converts the carbon dioxide into oxygen, it rebalances itself. So technically speaking, we're talking about a planet that's alive. And we've looked, believe me, and 25,000 light years in every direction in pretty good detail. There are no other planets like this. There's no other planet with life like this on the surface. So when solar flares occur from the sun, this is SOHO, which is just basically a chip out there in space and doesn't give us a lot of information. We can see these explosions come from the sun. These are highly charged particles that go racing through the universe in all directions, and sometimes they strike Earth. They take about 73 hours to get from the sun to here. When they get here, we have a magnetosphere around our planet that these particles route themselves around, and it protects us. We can see that sometimes our upper atmosphere responds to those particles that come into it by giving off light. They've taken in as much energy as they can take in, so now it's time to release some of that energy, and they do it in the form of visible light. This is actual satellite photography of the aurora around the Earth, high speed. It was 2007 when I first became involved with the expedition to the Hollow Earth. Stephen Curry was leading it in 2006. He contracted rapid onset brain cancer, and 6 months later he was gone. So all of us on the team basically said, well, that's it then. Stephen's not there, I guess we won't have an expedition. So then they called me in October and said, you want to lead the expedition? I said, well, let me think about it for a little bit because I'm kind of busy. But I called him back in a month and I said, yeah, well, let's see what we can do because some very strange things are happening. So we were going to go in the summer of 2008. And a very strange thing happened in the winter of 2007, 2008. It got warm in the Arctic, like abnormally warm, and the wind changed. What we call the polar vortex was then blowing across the Arctic instead of down from the Arctic into North America. And it cleaved off a big piece of ice. I mean, a state-sized piece of ice. We call it calving. So this big piece of ice broke off and floated away, and it opened up the Northwest Passage for the first time in, we don't know, maybe 20,000 years. So we thought, now's a good time to go. Of course, the economy went to crap, so there was no doing a $3 million expedition to the Arctic that year. But interestingly enough, going back to my ancestor, Sir James Ross, when he was looking for the North Magnetic Pole, he found this little seagull, which he called the Ross gull. Now, it doesn't look like a particularly wintry animal. It's kind of dainty. You wouldn't think much of it, except that this particular bird doesn't fly south for the winter. It flies north for the winter. It nests somewhere in the north. So I talked to the world's leading ornithologist in Scotland on this gull, and to this day, they do not know where this bird nests. It is not built for 90 below zero. It goes someplace where it's warm in the winter, and we don't know where that is. Washington University, very fine university, gathered up all these seismograms. Seismograms are printouts that happen every time we have an earthquake. You know those squiggly lines every time we have an earthquake? Well, of course, they're much better than that now. They're not just an ink line on a piece of paper. They're computerized. And they decided to go through 600,000 of these seismograms, put them into the computer, which is a lot of data entry, and then run a modeling program on it. Kind of like, doing a CAT scan of the Earth, taking all these vibrations over years and years and years and years, 600,000 of them, a lot of data. And what they discovered was another ocean underneath the crust. This is actually what they printed. This is their article right here. We concluded after 600,000 seismograms that deep in the Earth's mantle, there is revealed the existence of an underground water reservoir, at least the volume of the Arctic Ocean. You know what they picked up in the seismograms? The waves crashing on the shore, inside the crust, like 900 miles below the crust. The average earthquake is about 75 to 150 miles deep. The really devastating ones are about 15 to 20 miles deep, way further than we've ever drilled. We have no idea what goes on down there. And there's more. This is Jill Heinerth. She's an under ice diver photographer, probably the best in the world. She's been featured in like 50 different documentaries. And she filmed this where the crust is actually cracking open and filling in with molten material. Quite famous. And still alive, but not willing to go on the expedition with us because pretty beaten up from the constantly diving to 300 feet. So the other thing that happened was the NOAA, every 5 years, they do a survey of the ocean. They go to Malaysia and they sample rays, like stingrays and manta rays. If there's any kind of environmental stress, like pollution or chemistry changes or temperature changes or salinity changes, the rays respond by mutating. So every 5 years, they go to Malaysia, they net a bunch of rays, and they sample them. They see how many new changes, how many alterations that they've had. On average, they have about 50 every time they go. In 2008, they had 1,500. And they were not mutations. They were totally new species. And some of them were totally old species. This photograph in the upper left is called a frilled shark. Alive, mature, and extinct for 1 million years. In the upper right was a giant ray. The fishermen actually called it a squeaky alien. It was delicious, they said. In the very bottom, we have a dorsal squid, also extinct for over 1 million years. In the lower right is a fully mature ray, pretty good size. You can see it here with the fishermen that recovered it. Something happened, and another ocean, another ecology that's been in existence for millions of years maybe, started blending with our ocean. This is the way we kind of look at the way earthquakes happen. We have P waves, we have S waves, we call them pressure waves and shear waves. And we think that when there's an earthquake, these vibrations go through the earth. They're listened to by several listening stations around the planet. And this is what it kind of looks like in our textbooks. This is a typical textbook printout. You can see that you have the pressure waves, you have the shear waves, and then you have this crazy dotted line wave they call a shadow wave, because, as I told you, it's a kind of a religion. We already know the way our planet's made, right? So when we get vibrations we don't expect, we just call them shadow waves. And then another scientist decided, well, what if we do it another way? What if we take the vibrations we pick up and we work them backwards to the point of origin? Every single time, it comes out looking like this. There's no shadow zones. There's no mistaking this model. We have a crust, and then we have a void zone where the vibrations do not go through. There's only one way vibrations will not go through a zone, and that is if it's air. The vibrations stop there and don't go through the air and make a jump to the other side. They go around. So we decided to try and figure out what's in that void, what's in that hole. So they started listening. They listened with what we call a spectrometer. And what they discovered was that the frequency was dead on the element iron, bonded with another atom called xenon. If you have a bottle of soda with the cap on, you notice there's a little air gap at the top between the liquid and the cap. If you took a needle and you sampled that gas area above there, you should have a partial pressure of all the elements that are in the liquid. That's the law of partial pressures. So everything that's in the liquid should be in the gas. And that's what's wrong with our atmosphere. Because we should have a certain portion of xenon in our atmosphere, but it's not there. It's missing. It's been missing for a long, long time. We just didn't know why. We didn't know where the xenon was. It wasn't leaking out to space. It was bound up with something, but we couldn't find it. Turns out the core of the Earth is this giant iron xenon crystal, and it's at millions of degrees. That's the frequency that they're getting. Well, the only way to prove it, since we can't drill to the core, we don't really have a ship that can go to the core, is to duplicate it in the lab. They take a crucible that looks like this, and they put iron and infused it with xenon and crushed it beneath these diamonds. And then they shot lasers through the diamonds to heat it up to millions of degrees, and this is what they came up with. This is an iron xenon crystal. And at temperature, it is identical in frequency to the core of the Earth. And we believe that it's around 1,200 miles in diameter. Simple geometry to figure out the diameter of a planet. We see how long it takes to go around the sun, the distance between the planet and the sun, and we can gauge its weight. So we've always used the 1 gram rule. But turns out the 1 gram rule is wrong, that there are large sections of the planet that are way above 1 gram. 14.5 grams per cubic centimeter is very dense, a lot of pressure. So we look at the diameter of the Earth, we see how far the Earth is from the sun, we see this core, and we say, there's no way. There has to be a gap between this core and our crust. We estimate that gap to be somewhere around 1,000 miles. Anybody fly here? I flew here at 28,000 feet, but you could actually fly at about 40,000 feet, or maybe 50,000 feet. That's 7 miles. We're talking 1,000 miles of atmosphere between this core and the inside of the crust, where there's an ocean the size of the Arctic Ocean crashing inside right now. So now we have a structure. Now we have some data that begins to tell us what the Earth really looks like. By the way, the deepest hole we've ever drilled is only 8 miles. So we think that the crust is somewhere around 900 to 1,100 miles thick. And then there's a gap, and then there's a core. Now, but if this was true, and the crust did expand the way that we showed in Neil Adams' film, then the crust slowed down, didn't it? Like when the ice skater lets her arms out. The core should still be spinning at its original speed. And it turns out that this counter-rotation between a slow crust and a fast core is a generator. And that's what makes the magnetosphere around the planet. Turns out we're not the first ones to think of this. The Tibetans already knew it. They already diagrammed it. This upper left infrared picture of the Earth, you can see there's some kind of missing data at the pole, at the Arctic. And we can see the Tibetan mandala at the bottom. What about Newton? Okay, Newton had an idea called thin shell physics. And this is the formula. He basically said that once you're on the inside of any sphere, that gravity becomes zero. All the gravity cancels itself out in it. And regardless of the masses or the distance, the magnitudes of F1, force 1, and force 2 will always be equal. Newton's thin crust physics, we extrapolate into thick crust physics, because we ostensibly live on a thick crust, not a dimensionless single thin crust, like he theoretically said. So what does it look like? How does it work? It turns out when you apply Newton's physics to all the data that we just looked at, we get something that makes us realize that planets never form as solid balls. They always form as crusted spheres. So let's do a theoretical experiment. Let's say that this room is a giant elevator, and there's a shaft from this room to the center of the Earth. And we're all on bathroom scales. You don't have to tell me what you weigh. I weigh 0.1 metric tons. If the elevator went down to the center of the Earth, what do you think we would weigh? So if we take this elevator, we go down to the center of the Earth, right here, all the mass of the Earth is above us. There is nothing attracting us to the center. We're at the center. Our weight will be decreasing the closer we get to the center of the Earth, and the further above us the crust gets. On the inside of the planet, since you have this crust above you and the center of the Earth below you, that rate of acceleration drops off radically. The poles have to be thinner. Otherwise, the model doesn't work. It has to look something like this. And this is what we were trying to prove by making the trip to the Arctic to see if we can find that opening in the crust where the two oceans blend. And we're not the first ones to think of this. This is Tibetan Buddhism. You can see the model of the inner sun, or an inner energy force inside the Earth, and life energy coming from the inside of the planet. When I went to the bottom of the Patala, by the way, up till about 140 years ago, it was the tallest building in the world. It's in Lhasa. It's built out of straw, stacked straw. I wanted to go down into the basement of the Patala, and so I asked the Chinese guard who was standing there by the door with chains around the panic bar if we could go down. He shook his head. I said, wow, I came all the way from America. I'd really like to see what's down there. Oh, well. So I slowly began to walk away, and I felt a tap on my shoulder. It was the Chinese guard. I thought, I'm being arrested. This is it. No one at home's ever going to see me again. And he motioned back this way. He unlocked the chain, and he opened the door. The interesting thing that we found down there was something that no one in the West has seen before. By the way, it's not just there. It's also, this is the one in Tibet. Anybody been to Rosslyn Chapel? Did you look at the altar and then look up? You'll see this. Same exact symbol. A crusted earth with the inner sun. We've also seen it on other planets. Saturn's polar hexagon. This is Hurricane Katrina. You can see the energy forms this six-sided shape as it spins in very high energy. We also see it in Jupiter's polar vortex. We can also see it in Venus. We can also see it on Mars. We can also see it on Saturn. And this is the Antarctic with X-ray. So the auroras appear over both poles. It excites everybody, which gets everything going. And I think my friends down at JPL got excited about it too, because they decided to build this. This is called the Themis probe. They launched it on what's called expedited manner. That means no budget, guys. Get this done and get it launched. And it went up. They turned the experiment on, and what they were looking for was energy that was coming to Earth that was causing the aurora. And what happened was this bright spot that you see out there between satellites 4 and 5, they called it a cosmic bullet. It appeared out of nowhere, out of another dimension, this explosion of energy. Of course, it passed satellite 5 and went out into space. And then it passed 4, 3, 2, 1, struck the Earth, and there was the aurora. One time. And they said, that's the cause of the aurora borealis. Cosmic bullets. End of experiment. I'm not buying it. I wrote him and told him I'm not buying it. Let's run it again. They didn't have the money. We also have these reports of UFOs. Actually, over 76% of every society in the world believes in UFOs or has seen one. So the next question I ask is, where did they go when they're not flying around? Nobody knows the answer. Oh, it could be the bottom of the sea. James Gilliland and I have seen them go into and out of Mount Adams before. That's not the sea. That's solid granite. This is Mount Everest out the front window of our airplane. This is Mount Adams. We have 2 people there, 2 digital cameras, 2 different brands. Let's set them up on tripods, and something shows up in the upper left. And let's take pictures at the same time and see if we get it with both cameras. And lo and behold, we caught it, both cameras. And then this one showed up. Let me zoom in a little bit. We want to know how big it was. We shot it again, a little different angle. By our measurements, this is about 500 feet in diameter. We could not see it with our naked eye. And the several people there were saying, why is that? Why can we look up there in the broad daylight? We can't see this craft. But when we shoot with 2 cameras, we can see it. The chip in the camera does what's called oversampling. When we're looking analog. We're receiving a signal real time to the rods and cones in our eyes, and we actually have to move our eyes around a little bit to see things more clearly. But digital cameras don't do that. They'll take, in that snap, they'll take 200 pictures, and they'll overlay them all the way in the infrared, all the way in the ultraviolet, and they layer them. And the interesting thing about these craft is it appears that they're not really all there. That's why our naked eyes cannot see them. They can fly around with impunity. Radar doesn't really bounce off something like that, but digital cameras pick it up. They can't hide. And so you can see how fuzzy the edges are and how crystal clear the mountain is. It's not a blurry picture. It's a blurry craft. Because this is where the rotational energy of the core and the rotational energy of the crust gets interesting. It is not an indiscriminate morphing field. It tends to have structure to it. And the structure is so well known that we call them ley lines. They can be measured by all kinds of instruments. And we have mapped a lot of these. And when we put these together, they start looking something like this. We've seen this image before, have we not? We see it in the flower of life. We see it in all kinds of sacred geometry. We also see it in the morphogenic field of the human body. We are just like the planet. The planet is just like us, which means maybe we do have a conscious link. Maybe we do have a symbiotic relationship with our planet. And maybe the symbolism all fits together in a well-known shape that we know as the star tetrahedron. This is actually what the energy field of the planet looks like. It is what your energy field looks like in its rotational form. We know this as the Merkaba, right? Human consciousness is linked to these icons of sacred geometry. These are drawings that I photographed in Tibet. You think they understood about the energy of the earth? You think they saw the way all these lines connect together? This is known as the Mandala Building. It's in Shigatse, Tibet. By the way, this is 14,700 feet. But this is an interesting building because it lays out the connection from beginning to end of the creation of the planet itself and its synchronicity with the human being. There are 108 rooms in this, and it is a series of meditation enlightenments that you can go through going through this. And I actually made a film on the inside of the basket that's in the top of this thing. It was very difficult to get through, not because I couldn't breathe, because I couldn't get the words out of my mouth. It was that powerful. Very, very intense up there. Only one of these in the world. This is the Patala. And you can see why it's, up until 140 years ago, the tallest building in the world. It's way up there. In the basement of this, what we discovered was something no one in the West has seen. It looks like, well, not like this. What is this? This is Tesla's coil. Well, it turns out in the bottom of the Patala was this. Look at the rainbow energy around the statue of the Panchen Lama. By the way, it's lined with sapphires. That blue ring you see around there's all sapphires. Over 10,000 gems on this thing. Over a ton of gold. But this is the most interesting thing about this. Look at the top. You see the dish? You see the, looks like rings underneath it, like a spine. And you see the two wings coming down on either side and the ribbons wrapped around it. This is what the Tibetans saw. This is what they built. This is their Stargate transportational device. Well, it turns out Tesla did exactly the same thing in the 19th century, except he knew what to do with it. This is the stupa, and this is the Tesla coil overlaid right next to it. Some people say, well, it's the Spirit of God pouring out upon the earth, and everybody gets it and we interpret it in different ways. Maybe. Maybe it's the Spirit of the earth talking to us, and each generation gets this information, interprets it their own way, and they build pyramids, or they build stupas, or they build Tesla coils. A little bit off the subject, but if this is true, a little bit of deductive syllogism, we ask the question, then who built all that stuff? Why would they build that stuff for us? instead of them. It didn't make energy for them, didn't make any grain, didn't make them rich, didn't make them powerful. They couldn't dominate the world with it. Why did they spend all that time and money and effort to build it? It's because we're the ones that built it. We built it so that when we arrived at this time, in this age, we would remember who we are and why we're here and what we're supposed to be thinking about. Each time these things layer together, we get prophets, seers, great inventors that put these pieces together, receive these downloads of high technology and interpret it for us. And we kind of slap ourselves in the forehead and go, oh yeah. And we remember who we are. We are eternal beings having a mortal experience. But interesting thing, while I was there, I looked up a guy named Hani El-Zaini. Hani El-Zaini was the guy that exhumed Seti's temple. Seti built this temple out in the middle of the desert over another structure that was already there called the Osirian. The Osirian goes back maybe 11,500 years, way before. Seti knew it was there, sent his engineers out to find it. They found it, and he built his temple on top of it. And then the desert covered the whole thing. Well, Seti, also known as Dorothy Eddy, had a dream that she was the reincarnation of a priestess that worked at that temple. So she located it, and Hani El-Zaini was commissioned by Egypt to dig it out, and that's what they did. And she translated a lot of stuff. She translated a lot of the work by hand, and I held her book in my hands, and I found her hand translation of the hieroglyphs from Seti's temple. The interesting thing that I found is where it said, they escaped into the earth. That's unpublished. This only exists in this book. We have to go to the Arctic to see if this opening exists. We're going to leave from Murmansk, Russia. We're going to sail to Helsinki, and then around, and then all the way back to the point of origin. 15 days. We're going to survey 10,000 square miles of ocean in 15 days. It's mostly covered in ice. It is not a trip that can be made any other way. Can't be done by air. You could never do this by dog sled. Far too treacherous. The only way to do this, and to follow maybe in my great-grandfather, my great-great-uncle's steps, Sir James Ross, to conduct the greatest geological expedition in the history of the world, is to take this, the Arctica. They just finished building it. It is the world's largest nuclear-powered icebreaker. I say we can't go to the moon, we can't go to Mars, but we can do this. We can go to the North Pole. We'll break ice for 8 days. It's not for the faint of heart, but it's sure going to be fun watching those scientists cry. Yes. I'm going to show you what this boat looks like in its finished form. It looks like this. Yeah, there's no other boat like this in the world. This is the only ship in the world that can make this trip. 125 it will seat, and the crew is about 125 people. It has a 3.5-year fuel supply. No, we're not sailing it inside the planet. We're going to get close, and we're going to use that helicopter that you see on the helipad there, and we're going to fly over it and take pictures of it, and we're going to stream live, well, as live as we can, because there's no satellites that we can see from there. You know, the satellites exist in the southern sky. We're not in the southern sky. So what we're going to do is ping these packets to the western hemisphere, to the eastern, over in Europe, and then we will real-time those packets live as pay-per-view online. We think we can get about 10 to 12 million people to watch during this 15 days. We think that they'll pay $9 or $10 for the 2 weeks to watch it. We could be wrong. We could be throwing our money up a horse's ass too, but we think it will work out. By the way, it's the roughest seas on the planet. That little 100-foot boat that Brian Olsen took, no. This is a 300-foot boat, and this is gentle. We're talking 10-story seas. It's not going to be easy, but it will be worth it. So we think this Hollow Earth expedition is the ultimate myth buster. We're going to conduct a lot of mainstream stuff, maybe some global warming. We can get some money from the National Science Foundation. We're going to talk about the origin of human consciousness. We think if we take this ship 500 miles from the nearest other porch light, we'll be the only consciousness signal for a long ways. We think if we can get the consciousness of that boat to a certain point, if there is intelligent life around this opening or inside this opening, that they will come to see us. And when they do, we will get it on film, and you will see it the same as we see it. Every Sunday from 5 to 8 Pacific, I have a program called X Squared Radio. Some of you listen to it. All of you should listen to it. Because I want to tell you, you are Source. My name is Brooks Agnew. Thank you so much. Thank you. Thank you.